Today we're going to find the area of regular polygons. So who can remind me what is the name of a polygon with 5 sides? No? A pentagon. How about a 7-sided polygon? Marquise? Heptagon. And how about a 9-sided polygon, right? A nonagon. If you forget the names, you may need to go back to your chapter 3 notes. 3, 4, 3, 5, I think, is where we had a chart with all the sum of the interior, sum of the exterior, all that stuff. Because you'll see these names in the problems, in word problems, and you'll have to know what the numbers are. Alright, so just a reminder, a regular polygon is called regular because everything's the same. So all of its sides will be congruent, and all of its angles are congruent. So in a regular hexagon, I guess, all the sides would be congruent. I'm not going to mark all the angles, but we could mark all the angles as being congruent. Now, all regular polygons have what's called a circumscribed circle. Which means a circle that would fit outside of it, but touch perfectly at each of the vertices. Now, why is that important? Well, sometimes we will know the radius of the circle. The radius of the circle, remember, will touch the center, and it will touch a side of the circle. So you can draw the radius here, well, here, 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 here. It has to touch the edge of the circle and the center. So the center of the regular polygon will also be the center of the circumscribed circle. So these points will be the same. And then the radius, which we've already drawn in, the radius is the distance from the center to a vertex. Now here's a new vocabulary word for us. The apothem, or the apothem, some teachers say. I call it an apothem. The apothem of a regular polygon is the perpendicular distance from the center to a side. So up here, let's draw in another radius to make a triangle. So you see how we could split this up into a bunch of triangles? Right? So really, if you didn't know the formula, you could find the area of one triangle and then multiply it by 6, right? So we have 6 triangles, and they're all congruent. But we're going to learn a formula, makes it a little bit easier. Now to find the area of a triangle, though, remember you have to know the height of the triangle. That's going to be your apothem. So this is A. It also happens to be the height of the triangle. So looking at this picture, they have all of them drawn in, and we have little arrows pointing to things. So what is this arrow pointing to? What part of the picture is that? Is it the center, the radius, or the apothem? The center. How about this one? What's it pointing to? Radius or apothem? Apothem, because it's perpendicular. And the last one is touching the edge of the circle and the center, which makes it a radius. So below we have a couple formulas. Now, the formulas are all derived from the triangle. If you were to find the triangle, it would be 1/2 base height, and then you'd multiply by the number of triangles, which is the same as the number of sides. So the formula for this is 1/2 the product of the apothem, A, times the length of a side, S, times the number of sides, which will be n. Remember we used n for number of sides, like n equals 7, n equals 5. So the formula for the area of a regular polygon is 1/2 times A times n times S. This is really derived because the area of one triangle would be 1/2 base height, which the base is the side length. The height is actually the apothem, so you have 1/2 times A times S. And then you have how many triangles? 1, 2, 3, 4, 5. You would multiply by that, which is n, the number of sides, which is the number of triangles. So that's how this formula is created. But you can just memorize it and use it instead of having to do that. Now, the perimeter of a regular polygon. The perimeter, remember it's regular, would be one side length times the number of sides you have. So that would be n times S. Again, n representing the number of sides, and S representing one side length, because they're all the same. So an alternative form of this formula, if n times S is equal to P, you can actually say that the area is 1/2 A P. These are both formulas that can be used, depending on what information is given to you. So if I give you the perimeter, I'd use this formula. If I don't give you the perimeter, I would use this formula. If you want to just memorize one, you can, but it's kind of beneficial to know both. So we'll start out with the easy ones today, where they're just kind of plugging in and solving. Monday, we're going to look at harder ones, where we'll have to use SOHCAHTOA or special right triangles to find out what A is or what S is, and those will be the hardest ones. So find the area of the following regular pentagon. So we want to pick one of our formulas. Looking at this, I don't know the perimeter. So I would use my 1/2 A and S formula, personally. Then you need to find out what everything is. A is the apothem, so the apothem is the perpendicular distance, 3.2. N is the number of sides, which in a pentagon, N will be 5 sides. And S is the length of one side, which was given 4. And then you just plug in. Multiply all that together, and we do want to make sure we have square meters. Question 2. Find the perimeter of a regular polygon if A equals 7 centimeters and area equals 182. So this one wants me to find perimeter, so I'm going to use 1/2 AP, because I want to find out what P is. Substitute in what you know. Area is 182. The apothem, small a, be careful with your big A and small a. I know some of you always use capital letters or lowercase. In this instance, they represent different things. How do I solve for P? A couple ways to do it. Maddie? You can do either one. So she said, can you multiply by the reciprocal 2 on both sides? Yes. And then divide by 7. Or you can actually just multiply these together, get 7 halves or 3.5. And then undo multiplication with division. I think this would be probably your preferred method, but I don't know. Now the perimeter gets what type of units? Remember, the perimeter would be the distance around the shape. Just regular centimeters. Units will be worth a half point on all of next problems on your test. Make sure you pay attention to them. All right, next one. Find the number of sides n of a regular polygon given the following information. So since they want me to find out what n is, I would use the formula that has n in it. So 1/2 ans. And I should mention, if you prefer to do ans all over 2 instead of 1/2, that's the same thing. So if you like this better than this, those are the same formulas. All right, substitute what you know. Areas, 2,475. The apothem is 27.5. The number of sides we don't know, so I'll leave that as n. And a side length is 20. Now you have options. You can do this a ton of different ways, but all of these things are being multiplied together. The order in which you multiply them doesn't matter. So you can multiply all 3 of these things together and then divide by that product, which is what I suggest doing. So half of 20 is 10. 10 times 27.5 would be 275. So if you want to do it mentally, just multiply things that you know the product. Otherwise, use your calculator. Now we use inverse operations. We'll undo multiplication with division. And we should get 9. This would not be inches. This would be the number of sides. So this would be 9 sides, or you could also call it a nonagon. See if you guys can try number 4 on your own. So that was just a basic plug-in, and so you do want to use this formula because they gave you p, so that indicates use the one that has the p in it. All right, last one. They ask us to find 2 things. They give us a bunch of information: area, perimeter, and side length. The first thing they want us to find is A, the apothem. So, what formula do you think I should use? What formula should I use first? Joseph?
1/2.
Yes. If you choose 1/2 ans, you don't know what n is. And you don't know what a is, so you'd have 2 unknown values. So if you start with that one, you'll realize quickly, I don't know enough information. Switch it. All right, substitute in what you do now. Area is that 1/2 times a. Perimeter is 168. Again, you can divide by this and multiply by 2, or you can just multiply those 2 things together first. So we'll get 84 times a, and then the inverse of multiplying is dividing. And the apothem, we should get 26.1. What kind of units go on the apothem? Regular centimeters. right, to find n, you have two options. One of them is to use the area. The other is to use the perimeter. One of them is significantly shorter than the other. What's the formula for perimeter? Brett? P equals the number of sides times the side length. The perimeter is 168. The number of sides we don't know. The side length is 14. Simple. Divide by 14, we get 12. Anyone remember what that is called? A 12-sided polygon? Brett?
Isn't it like a dodecahedron?
Yes. Now, if you choose the other method, which is the longer one, you would use your 1/2 ANS formula, and you would actually use the answer from part 1 and plug in. Okay, I'm not going to finish the problem, but you would get the same answer. All right, now on the closure, they give you a little chart, and they want you to fill in the missing variables. So in the first row, we have a 7-sided polygon. Each side is 10. They want you to find the perimeter and the area. They give you a 9-sided polygon. They don't tell you what the side is. They do tell you what the apothem and the perimeter are. They want you to find out what the area is. So again, you may want to jot down the formulas that you know at the top of the columns. So perimeter equals n times s. Area equals 1/2 ANS or 1/2 KP. So see if you can fill out the missing boxes while I pass out your homework.